Good afternoon. I'm Dr. Kanade. We will start our first practical of the subject Advanced Microcontroller and its applications. I will share with you one screen, one very simple document which will tell you what we are going to do and what we are required to do. Okay. Our first practical name is Introduction to Practical 1. Title is Introduction to MPLAB IDE. Now, what we are going to see in this practical. Okay. Uh, Before starting with this, we must understand, or all of you must understand, what we are studying in the subject and some of the basics about that. The subject is Advanced Microcontroller and its applications. This microcontroller that we are studying is PIC18F458. Now we have already covered 3 lectures where we have seen the architecture of the PIC18F microcontroller. Okay, you have to remember this IC number PIC18F458. Okay, you must remember this particular IC number also, 458 also. Okay, this microcontroller is developed and manufactured by Microchip company. Okay, you can buy this microcontroller from the market. It is available in Pune also. I will not tell the price because the prices will vary depending on quantity and the shop and everything. Okay, anyway, the software that is required to write the programs for this microcontroller is provided by Microchip company itself for free. Okay, the software is available to us for free. You can download it directly from their own website. The software we are going to use is MPLAB IDE 8.92. This is the latest version of this IDE. MPLAB IDE version 8.92. Okay, this version. Okay, now let me clarify some things right now. In our course, the practicals will involve to write certain programs in embedded C programming language. It is very similar to C language. In fact, it is almost the same structure of C language. Some of the instructions and the way of writing the instructions will be different, but you should be familiar with C programming. Okay, and we will write all our practicals in C programming language. Okay, and for writing C programs, of course, you need certain software. Earlier in NMCP, you have used some kind of a software called Turbo C, right? You have used Turbo C for writing your NMCP practicals in C program. However, we cannot use that directly here. For writing programs for this particular IC, we need a separate software which is called MPLAB IDE. Okay, now this is only the software part. For hardware part, we have 10 kits in our lab of PIC18F458 IC. The called PIC PIC microcontroller development boards. We have 10 quantities of that. Okay, so these practicals will not be only software based practicals. There will be a combination of software and hardware. In the beginning, we need only software, but at later stages, we will need the hardware also. Okay. Next time, I will also show you this board and how it is organized and everything. Okay. Now, this IDE word I have been using multiple number of times. This IDE stands for Integrated Development Environment. Okay. Like what you have already seen, the Turbo C. It is not only a compiler; it is also a IDE. It is also an integrated development environment where all the tools required for programming are combined together. What are the tools? You need first a text editor for writing your programs. You need a compiler. You need a linker. You need a debugger. All these things are combined in a concise way so that it becomes easier to write and create your programs and also to troubleshoot your programs. Okay, so this kind of an ID is provided by the microchip company. It is called MPLAB IDE, and its latest version is 8.92. Okay, remember I am telling you the version 8.92. Do not use the MPLAB X IDE. Okay, do not use that MPLAB X. If you you can download and install this IDE on your own, and some of the practicals also you can perform on your own if you have a PC or laptop. Okay, so those who have PCs at their home or laptops at their home, they can try to download this software. You just type these words MPLAB IDE 8.92 download in your Google, and you will get the link for downloading. Okay, it is a simple installation process. You simply install it by using the default by using all its default configuration. Okay, additionally we need a separate download which is called MPLAB C18 compiler. This is a separate this download is available separately, again free of cost, from the same company. So this also you will have to search and download it and install it. The files will look like this. This is the file for MPLAB IDE 8.92. It is a zip file, and the C18 compiler file will look like this. MPLAB C18 v3.47 Windows Eval installer. Okay, so these two files you will have to download and then simply install. Okay, once you install these two software on your computer, you can perform today's practical also on your own. Okay, in case you don't have, we will whenever you come back to the college, we have this software and both the software and the hardware installed in our lab, and all these practicals you can perform at that time. Okay, so this is some things which you must note down, that what are the requirements for this practical. And additionally you should remember that whatever we are learning today, what we are going to learn today is how to use this IDE, okay, for creating or writing your own programs. This is going to be useful for all the remaining practicals. We are going to cover total nine practicals, and for all these practicals you will have to use this MPLAB IDE, and that's why you must take utmost care that you understand thoroughly how this IDE is used. Okay, now I will stop the share and I will start the MPLAB IDE and show you how it looks like. Okay, just you have to wait a little bit, just a minute. Okay, now I'm going to share with you. Okay, now you can see the MPLAB IDE here. Okay, I have opened the MPLAB IDE on my screen. Okay, on the toolbar, on the title bar, you can read MPLAB IDE version 8.92. Okay, so if you have used some kind of a programming tool earlier, or some kind of a, if you have used programming language other than C, or in C, if you have used some other IDE like Dev C++ or Visual C++ or Visual Studio, then you may recognize this kind of configuration, or even MATLAB. Okay, anyway, by default what you see here is untitled workspace. Here it is written files. Here is the output window and some blank space here. Okay, so this is how our IDE is going to start. Now when we want to write our first program, what we have to do is we have to click on the project and click on the project wizard. Okay, when you click on project wizard, a small window of project wizard titled project wizard will open, and which will give us step-by-step information about how to create our first project in the MPLAB IDE for PKTNA 458. Okay, so when you click next, the first the step one is to select a device. Device means the IC that we are going to use for programming. Now you can see this software we can use for programming so many different ICs or so many different controllers given by the same microchip company. Okay, among that we have to only select what we want. We want to program PIC 18F458. Okay, during our practicals we are going to use only the single IC. In this subject, in this course, we are going to study only the PIC 18F458 IC. That's why this is what we must select. If we select a different IC, then the program may not work. Okay, so remember, this choice must be correct. Okay, once we select this device, we have to click next, and on the next page you will see some very important selections to be made. Here, active toolsuit. In the step 2, we have to select a language toolsuit, means what language we are going to use for programming. Now we are going to study 2 languages for PIC18F. The first one is the assembly language programming, and second one is C language programming for PIC18F458. As far as the practicals are concerned, we are all going to perform these practicals in C language. That's why in the active toolsuit we must select microchip C18 toolsuit. Okay, microchip C18 toolsuit. This is what we must select, and this toolsuit now contains some multiple things, out of which we have to select MPLAB C18 C compiler, mcc18.exe. MPLAB, remember what is the name? MPLAB C18 C compiler. Okay, so this compiler is part of this microchip C18 toolsuit. Okay, if you remember, a while ago I have told you, along with the MPLAB IDE you have also to install the microchip C18 toolsuit, right? If you don't install that, this option will not be available to you. Okay, this C compiler will not be available to you, and if it is not available, of course you cannot perform our practicals. Okay, now then once we select this C18 compiler, we have to go next, and we have to create a new project file. Now most of the times I have experienced that students write some name here, go next, perform practical, and when they come back to in the next practical, they don't remember where they have written their code, where they have performed their practicals. So remember, not only writing the name, but where you are creating your project, that is also very important. So you must click on browse. So this kind of a window will open, save project as. Where are you saving this project? You can save at any location in the computer. Okay, but the point is you must name some, you must create some folder where you will put all your programs. Okay, otherwise if you just randomly write down something, then it will not work. It will work, but you will not find where you have written your program. Now let's say I'm creating this project and I'm giving name SGK2. Okay, and this is where I am writing in my drive somewhere MPLAB programs folder. Okay, you should choose your own path, and you should save your all your programs or all your projects in a single folder probably, so that you can organize them in a better way later on. Okay, so I just named my project as SGK2. Remember, the name I'm using here is project. Okay, and I am saving it here. Okay, so this is where my project is getting created. Now I am clicking in next. So all this step 4 is actually useful when you have some programs already written which you want to use inside this project. Some basic functions probably you have written, and you want to use those functions in this. In the beginning, we will not go for that. We'll just create an empty project. I'm calling it. Okay. So when I click next here, this is the final summary of the project, and you must ensure that all this summary is correct. The most important one, the IC PIC18F45 device we are using, and the toolsuit you are using is microchip C18 toolsuit. Means we are going to write a C program in the in this project, and the project file title is here. Okay. When I click finish, the project will open like this. SGK2 was the name that I have given, and MCP is microchip project. Okay. So here we have now the project structure. Okay. In source file, if I double click, I have nothing. Header files, I have nothing. What it means, that we have just created a blank project or empty project. Okay. Now the next step is to write the program for this, to write down a program for write down the program for whatever we want to perform, whatever operations we want to perform. Okay. So there are two ways. One is you click here. What is this? New file. Okay. Or from file also you can have new. Okay. So it will open an editor like this. Okay. And here we can write our program. So as usual, the first line is hash include P18F458H dot H. Now, do you remember what this hash include is? It is, as I said, this is going to be a C program, and in C program you must include the whatever header files are required in your program at the very beginning. So that is what I have included here. Hash include P18F458.H. This name is required, and this name corresponds to the IC that you are using. This is actually the same name of the IC, P18F458. Okay. Then here we are going to write our program. As usual, there will be certain preprocessor directives. Okay. Preprocessor directives, and after that we start with void main, starting curly bracket, and then we again write our program, our instructions, and then we complete the bracket. This is how our program, basic structure of our program is. So you can see here that it is exactly the same structure as we have used for our, which one? For our C programs, the standard C programs that you have written in your NMCP, let's say NMCP practicals. This is how the C program will look like. Okay. Now, once you're, I'm in the beginning just telling you how the program has to be written and what are the things that are required. I'm telling you the procedure for writing and creating our projects. Okay. So once you type all your program here, all the instructions here, we must save this program, and for that we have this save file icon here. If you click on this, you can get the save button, or from here also file save. It's the same thing. Okay. So now I'm going to click on this. Okay. So I will get again this kind of a window, save as. Okay. And I'm going to save this, let's say math ops, mathematical operations. Okay. Here you must type .c as an extension. Remember this, you must write the .c extension to the file name, so that the file will be created with a math, the name whatever I'm giving math _ops.c. Okay. and I will save this file. Okay. Okay, so this is how the file will be created. Now when I save this as .c, you can see the color has changed. Okay, this hash include and void became blue. Okay, why this? Because these are the keywords in C language. Okay, this coloring happens automatically by this IDE, so that you can you can recognize the typed words in a better way. Okay, so this is very helpful when you save the program. Now after saving the program, what is the standard step that you use to perform? Anybody can tell me what is the standard step? Yes, somebody tell me what is this, what should be the next step?
Compile and run.
Compile. Okay. Okay. Anything else? Anybody wants to change whatever he has said?
Start stop debug section.
Start stop debug section. Okay. Now what I will do, I will instead instead of this code, I will just put some actual code here. These things you in the beginning you just ignore. These are just required things which you cannot understand right now. I will go in the, see here is the void main section, starting curly bracket, and then again certain instructions which we will have to skip for now because these are different. These are difficult for you to understand right now. Just thing is A, B, C, D, E, F. These are the variables that we need. And what this simple program is going to do is, there are three variables A, B, and C. In variable D, we will save A plus B. In variable E, we will save C minus B. In variable F, we will save A into B. Okay. And after doing this, we will send this value to port B, send value E to port C, and send value F to port D. Okay. Now what are these port B, port C, port D? These are the ports of the microcontroller. Okay. In the architecture lecture, we have seen that this microcontroller has 5 ports, A, B, C, D, E. Those are named as port A, port B, port C, port D, port E. Okay. So what we are doing, just we are having 3 values here. We are performing some basic mathematical operations on that and sending the results to 3 different ports. Okay, these are 8-bit values which we are going to send to the ports. Okay, now this is the program that we wrote. Okay, now what somebody said is the next step should be compile. Okay, now compiling, actually it's called build. Okay, so if you can see here this icon, build all. Okay, so if I click on this build all, let's see what happens. What happened? This is the output of the whatever the process we perform. The build has failed. Okay. Now, if you see this program, well, as you don't really know what exactly the program and these commands are doing, you may not be able to find out the errors, but I can tell you that there are no errors. There are absolutely no errors in the program. Okay, but still the build has failed. Now, this is because we have missed one very important step after writing the program. Okay, see, we have written the program, we have saved the program in math_ops.c file. Okay, but this file has not been included in our project. Okay,
Build target.
what we have to do after writing and saving the program, we must add this file to the project. And how we do this? Here on the left hand side, you see this project window, and this was the project name that we have given in the beginning. Under that, there is source files. On this source file, you right click, say add files, click on add files, and select the file that we have just select the program that we have just saved. Okay, math_ops.c. we have now added this. Okay, we have to save this project. Okay, and now try to build. Now you can see the build succeeded. Means the whole project has been compiled and now it is ready to be run somewhere. Now obviously somewhere means what? Where do we want to run this program? Ideally we want to run this program in the PIC18F458 IC, or actually on the kit. But since we don't have the kit right now, and anyway for this first practical we are not going to use the kit, there is another option of using the software based debugging. Okay, now what we can do here is, on this menu bar we have debugger. Here you can select tools and the option here MPLAB sim we have here. Okay, you select this option MPLAB sim. If you have noticed, this toolbar has appeared here on this side. Okay, this small toolbar has now again appeared on this side. Okay, from here we can run the program. Okay, so if you start running, you pay attention to this bottom side also, because here you get this status whatever is happening. So if I run this, you can see in the bottom left corner, running. The program is now running. Okay, now again the problem, where is it running or what is happening, how can I see? So for that there is another option in the menu bar view. Here you have the option watch. Where I'm going? In the view menu, watch. So when I open this watch window opens up. Okay, now here you can see here we have a lot of names, let's say right now, which we can select. These names are the SFR, the special function registers that are available inside the microcontroller. Okay, so we can select whatever we want, whatever values we want to watch, we can select here. So what we want to watch? Port B. So I will select port B here and click on the add SFR. Then I will select port C, add SFR, and select port D, add SFR, because I want to see the values of these three ports after execution of the program. Okay, now if I close this and again open this, I don't have any values yet. What I will have to do is I will have to pause or halt the program. Okay, and then I can see the values here. Okay, now I can see what is the content of port B. This address you right now, okay, you can take this as your homework. Why these addresses are, or how, from where these addresses are coming. Okay, the port B is the symbol name and its value is now 0x11. Port C value is 0x78. Port D value is 0x48. Now what are the expected values? Now your today's job is, you have these values: A equal to 09 hexadecimal, B is equal to 08 hexadecimal value, and C is equal to 80 hexadecimal value. And in port B, what is the value? D. D is A plus B, means 9 plus 8 hexadecimal values. So are they correct? Is it correct? In port B we have 0x11. 0x in the beginning stands for hexadecimal. Okay, So the addition of A and B is 0x11. C minus B is 0x78, and A into B is 0x48. Okay, so these values have been calculated here and have been copied into the port B, port C, and port D. Okay, so this is what is about the first practical, where we have seen how to start the MPLAB IDE, how to create a first project, empty project, how to write our first program in embedded C language, how to add that program to the project, how to compile that program, how to run that program, and how to see the output of the program. Okay, I will quickly revise what we have done. How when we start in the beginning, we can create the new project using by clicking on project new, select the correct IC PEAK 18F458, then select the correct compiler, then give correct name to your project, then start writing your program in a new file from here. Save your new file with a .c extension, add that file to the project by using add files, then build from here, then select the debugger from select tool MPLAB sim, then run it from here. From view, add a watch, add whatever registers you want to see the values using the add SFR button, and then once you halt the program, you will see the outputs of the values inside those particular registers. Okay, so now this is actually our first practical. You just ping me how many of you have the software or can run this program, this software on your own if you have your PCs or laptop. Just to make a note. No, nothing. It's not like that. We can change that situation. Okay, on AMA group. Okay, and if you have any questions, please post. You can ask in the live session also. Okay, any questions? Yes.
Sir, from where that addresses has come?
Which addresses? I just told you.
After running.
You have to take it as a homework. You mean the watch addresses, right?
Yes, yes.
Yeah, that is what I told you, that you find out the solution. Okay, there is a hint also. All these are hexadecimal addresses. I'll tell you some hints. These are hexadecimal addresses. Okay, and all the 4 MSBs are F, means 1111. Okay. Additionally, I will tell you the hint that these are SFRs. Okay, and the last hint I am telling you, these are part of data memory. Okay, what are the things I have told you? These are part of data memory. These are SFRs.
SFR.
Yes, SFR means special function registers. The word you can remember SFR, and they are part of data memory, and all the 4 MSBs are F of all these. So try to find out this, that where you can find this. And of course you have all these answers in the PEAK 18F45 data sheet. Okay, you can download that also from the, you just type PEAK 18F458 data sheet. Okay, you will get that data sheet. I'm going to upload all these things on Moodle also, so you will probably find that. And also I'm going to upload this video on YouTube also.